Hello, welcome to Unit 13B. This is the second option in Unit 13. And this deals with machine translation, so training a machine learning model to translate text from one language like English to another language like Spanish or vice versa. Although we'll also look at um, other multi-language translation systems, and these networks can be used to apply to a number of other problems here. So, as with the 13A option, this notebook is also broken down into two sections. Section 1 introduces you to a new topic, and in this case, it's encoder-decoder networks, also called sequence-to-sequence networks. So we'll look at some resources there and do that. I'll come back to that in a sec. But Section 2 then is a kind of hands-on coding-based walkthrough. So we'll actually walk through and create one of these models and answer some questions about that for this. So let's jump back up to section 1. So the first thing I want you to do is read a little bit about an introduction to encoder-decoder networks or sequence-to-sequence networks. These are three pretty good sources here. This is just a general introduction to sequence-to-sequence networks and how they work. Towards Data Science has another blog on this. Now, this is part of the Medium League, and so if you haven't paid, you're limited to how many stories you can watch, or read. So if you're out of those, I have those other blocks here, although to look at, and then sequence to sequence stuff here. This is just a nice video, 10-minute or 9-minute video from AI Journal that kind of walks through these sequence to sequence networks. So pick one of those and watch that, and then answer this question in the write-up, just describing these models and why we might use them. So I mean, the whole idea of sequence to sequence models is that we are feeding it in a sequence of letters, and then we're converting that to another sequence. We're outputting a sequence of words. So I said letters. We're inputting a sequence of words generally, and outputting another sequence of words. So that's why we call these things sequence to sequence network. We call them encoder-decoder networks because of the general format. We have input, we feed it into an encoder that creates an internal state, and that state is fed to a decoder, which is fed to an output area. So kind of the idea is that you might input an English language sentence, and it would translate it to some internal state, some representation of the meaning of that sentence, and then that internal state is then fed to a decoder, which will decode this into a different language for us to use. So here's another view of this, where this is using long short-term memory nodes here. So you're feeding in this to a sequence of long short-term memory nodes, and then you have some conversion here, and then this is the output or decoding. So you're encoding and then decoding. So so let's look a little bit at what these are doing now. We're feeding in words, so sometimes you see models like this feeding in letters at a time, and we can encode letters relatively simple by assigning a number to each letter in the alphabet. So that might be 26 letters in the alphabet, but maybe more if you're working about uppercase punctuation, so maybe 120 or so letters that you have to encode. But the problem with letters is you have to build up complex meanings, words from there, and then words onward. And so these models often work at the word level. So we're encoding each word here and feeding in words into this sequence. But not all words are as important. There's a lot, if you look through a sentence, your mind automatically skips over certain words that may not be as important as other words. Sorry, I didn't mean to click on that. So things like the and it and has often are not so critical. So there's a mechanism to well, one way is that older models would just drop out a whole bunch of these words from the models, but they do sometimes have importance in certain words, in certain sentences. So instead, what we've been doing is training an attention mechanism, a separate little network that will try to suggest how important each word is in a sentence. So this is a quote from this attention article, and want you to read that. And then this is an article about the attention mechanism here that you can read through what it is and how it's set up. So again, what we're doing is we're maybe passing this word, a sequence of sentences into our network, and then we're creating some internal representation, and then we're outputting it in another language. So we're encoding and decoding this. But we want to also apply some importance. So as we're decoding it, we're also learning how important the different parts of this sentence is. So we'll try to code this as being important or not important here. So that's the basic layout of attention mechanisms, and that a lot of these encoder-decoders networks now have one of those built into this. Now this has been cutting edge for a while, but things change. So in the last just few years here, a couple of years, Google has been working on a new version of this. Their old version of encoder-decoder networks were called Google's Neural Machine Translation Networks, NMT models. And they were just basically this, what we've been talking about so far, this encoder-decoder network, sequence-to-sequence network with attention built into it. Now, Google has been last couple of years working on this massively multilingual, massive neural network machine model. And so that model creates one, rather than doing an internal representation for each language, it creates a shared representation from lots of languages. So we mentioned before we might be inputting English and encoding that into an internal state and doing that. But the old models, each language to language, so from English to Spanish, we used a certain internal state here. When we encoded from English to German, we had a different network with a different internal state. Google is now feeding these multiple languages into one central big network and having one shared state. So their goal is then almost to be able to go from swap out these pieces basically. So once you've got this internal state and everything's trained to and from that internal state, you can then encode a one language, feed one language in here and decode from another language, and then just swap the encoder out for different languages. What that'll allow us to do is do translations between multiple languages more fluidly. So especially for languages out there where there are less data out there, it's hard to train encoders things. And even there might be lots of examples of maybe English to some language. So like English to Ojibwe or Anishinaabe is a Native American language in our area of the Midwest. But there might be, there are limited examples, encoding examples of that. Our data set is still relatively small for going English to Anishinaabe. But there's even less of a corpus of going from German to Anishinaabe. And so you would never be able to encode something like that for this. So read about this Google's new M4 system on the blog, and then you can answer some question about that. Okay, so once you've got the basics of that, let's go on and look at an actual code base, kind of peek under a hood at one of these systems for us. So again, so this is a sequence-to-sequence or encoder-decoder network here with attention here. So this is kind of how we show an attention matrix here. And this shows the words in Spanish and in English here. And then the most important words, I believe, are highlighted in yellow here as we go. Yeah, so the strongest words are yellow, but one thing we'll often see is that some of the yellow words are just very common words like you here, pronouns or nouns and stuff like that. So besides looking at the yellow ones, the words in green are often important. And this also shows how important each word in English is translated to each word in Spanish and vice versa here. So basically you can see this like at is mainly tied to this casa uh, uh, tie here. So very important in translating that, but not as important as translating other things here. So it kind of just shows you how important certain words are in the translation or formation of the other words in this translated sentence. Okay, so we import our libraries here. This is um, a model from Google, and so Google uses the number of other libraries that we don't usually include. So there's some additional libraries imported here. We're downloading this again. This comes from a Google example. I think I have that linked up here. Here, it's this Google example here. So this code largely comes from right from this machine learning example here and how it's set up. So most of this is set up from here. So again, the way they do things is slightly different than what we've been doing in our class, but very similar. So now we're going to download this data set. This is a English to Spanish data set that we're going to import. So we're going to download the words. We're going to kind of process those words, check some punctuation, spelling, and do some processing here. So as in the other 13A, a lot of this code gets more complicated because we're getting into very complicated networks where we can't just build and train the network with a single line or two. If you remember back when we did support vector machines, we could just load the sentence or the data in with a command or two, a line or two, and then set up the model in a single line and then train the model. But now we're processing more complicated words and stuff, and there's not as much built-in stuff to support this currently, and so we're doing a lot more stuff by hand. Hand coding. So again, I don't expect you to understand all this code. Just run it and see, and we'll ask you point out certain things about it and see if you can and ask you questions about some of this. So again, what we end up with a data set, an English and a Spanish data set, and so we have corresponding sentences. So we have a sentence in English and a sentence in Spanish. And so we have a whole bunch of these sentences in English and Spanish. And the sentences have already been translated, and so from these we should learn, hopefully the network will learn how to translate from English to Spanish. We have to then tokenize this one, and what we're going to do is we're going to assign a number to every word in English and Spanish for this, and assign that. And generally we assign 1 to the most common word and 2 to the next one, and so on. For this. Now this is a large data set, and to kind of save you time, and for the example, there's more than 100,000 sentences at this. It takes a long time to train, so we're actually going to be limiting this to 30,000 sentences, just so we can kind of run it in here for us. And then we're going to break our data into training data and validation data with an 80-20 split, as we've done before. So we'll end up with 24,000 sentences in English and Spanish, and then we'll have a validation set of 6,000 for this to see how it does. So now again, I was telling you about a word mapping. We're creating word mappings for everything. So here's an example of the word mapping. So here's a language in English. I'll be watching you. So be is a pretty common word, and so that's probably the 40th common word in our language. Watching is assigned number 408. So it's a less common word here. You is again very common. It's assigned 6. Things like we have a marker for the start and the end of sentences. Those are of course very common. And even words like I and stuff. Now some of the punctuation is taken out. So IL is broken up into I and L here. So there's some issues there. And then similar for Spanish. This is the Spanish version of that. And each word in Spanish is assigned a number for this. So now we have to set this data up into certain batches so we can feed it into our network, and I'm not going to go into too much of that here. So here's our encoder-decoder model. So we start feeding the words in one at a time in English, and then we have some internal state, and then that is then translated into Spanish, and our output is Spanish. So we kind of have an encoder-decoder network here with the result being the second half of this, which is the Spanish language for this. And then we add in here an attention, little mini attention network, which will look at the words as they go through this and learn to rate which ones are most important and feed that information into this system. So again, I'm not going to go over how we calculate this and what the attention mechanism is. That's way beyond the scope of this class for this. So you can skip over that part. So here we're creating an encoder class and defining that it is made up of basically what is called an embedding network or layer, and then a recurrent network. Now sometimes these are long short-term memory networks, but in this case they're GRU gated recurrent units, which is, if you remember correctly, if you remember from a previous unit, those were kind of simplified versions of long short-term memory networks. It simplified some things, but actually then performed better than them. So that's our setup, is basically just some input unit and an embedding unit, and then one layer of this recurrent network here. Now that's one encoder, and then we'll actually create a number of these encoder networks here. This is our attention mechanism layer, and again, I'm not going to go over that. That's kind of beyond the scope of this course here, but we create an attention layer, and then we create a decoding layer, similarly encoding, and then a gated recurrent unit layer, and then a dense layer output here. So eventually we're going to build our whole network up from these parts. So we're going to create our encoder and decoder networks and set this all up here. So that's the whole idea of this sort of network. One challenge with this is that it trains a little different than we have before. So we have to define our own step training function to how these trains this. I would expect in another year or two, a lot of this stuff will be built into the libraries here, and you will be able to find these very simply. But again, this is all relatively new stuff, so it's not built into the libraries so well. But here's our training. One thing you can watch is the epochs. This is how much training we're going to go, how many times through the sentences we're going to go through as we train this network. So you can actually change this if you want to do more training time. So here we're going through this training, and it's hard to calculate an accuracy here, how accurate it is one translation to the other, but we do want to look at the loss. And so the loss is how much we're learning, and so this should be going down over time. So we start off with a loss that's quite high, and then that loss should start dropping down lower and lower. And when that loss gets close to zero, that means training isn't helpful very much. But even here, after 10 epochs, we're still getting a fair amount of loss, so it could probably use some training some more. But again, we have limited time here, and this is going to take some time to run. We'll just leave it as is. Unless you want to try it, you're free to increase the epochs and see if you see an improvement. Now we're going to evaluate this. We're going to give it a sentence, have it translate that from English to Spanish here, and I'm not going to again go through this language here. And we're also going to plot the attention stuff. So we have some language or some routines here. And then we get down here, and here we're actually going to do some sample outputs. So we're going to ask it to translate this sentence, and it is going to create a attention map showing how things are. And so the yellow is the most important, but again, often those are linked to really common words that are like a period or something like that is mapped to stuff. So sometimes the yellow ones aren't as critical as the green ones here. So the green ones tend to link. So here we have cold and frio linked, very, and mucho being linked here. So although there are other words that are contributing to this, or the word cold is contributing to certainly this word in Spanish, but also these other words. So you can kind of see uh, how the network relates and uses multiple words to figure out each word in this language. So and then, oops, where's the actual translation? Here. So we inputted, I guess we're doing Spanish to English here. I thought we were going the other way around, but I was mistaken. So we're speeding in a Spanish word sentence, and here's the output in English for this. And again, we go through a couple examples of this, and then you can answer some questions. You're feel free to input your own words here and see how that works. So you can just put in your own words here. Now, one thing, there is this U in front of these strings. You may not have seen that before. Sometimes we see a B if these are encoded in bytes, and these are actually encoded in Unicode, so they can be, because the Spanish language has some slightly different character options than ours. So the U just means that this is a Unicode encoded sentence, but this is the stuff in the quotes inside the single or double quotes is the actual sentence that you can try, different ones. So we just go through this, see how it works, and then there's a set of questions that you need to answer related to this. So hope you enjoyed this.